All right, we'll start. Hello, everyone, and welcome to Marshmallow Room, or what I would like to call is my second favorite minimum SDK version. And my name is Jitin Sharma. I'm working as an Android engineer at a company called GO-JEK. I'm from Bangalore, India. And I'm going to be talking about dependency injection, and I hope you're all excited. All right. Are you guys excited now? So I've been working with Android for about 5 years now, and that's the only platform I've done some serious work with. If I exclude all the side projects which I don't finish. So dependency injection is something when you work with Android, it doesn't really work around with the general Android concepts where you work with activities, services, fragments, and mostly UI. So when I started out with dependency injection, it felt like a very complex subject, and it didn't fit in Android at all. And in Android's context, Dagger is the only library which has survived the test of time and is kind of important regarding dependency injection. So, and it's complex. Dependency injection is complex because it kind of affects your whole application itself. And when it comes to mobile platforms like Android, where platforms put limitations there, it's not easy to maintain and create a library. So we've had libraries before, but none of them exist today. I'm sure anyone who has gone through Dagger must have seen this page at least once. Is the Dagger's documentation, which is kind of pathetic if you want to understand dependency injection and Dagger. The first thing I had to Google after seeing this page is what is a thermosiphon. Well, that's a word we don't usually use in conversations. So that's a bad UX right there. And Dagger is weird, and Dagger has a lot of stuff going around, a lot of annotation, a lot of interfaces. And this was me initially with Dagger, what's happening, what is this component, what is this module. And even Twitter agrees with me, So this is a legit news source for me when it comes to development news. Sorry. So let's come back to the base concept, dependency injection. So if I take a definition from internet, dependency injection is a technique where one object supplies dependencies to another object, which is simple. For example, if we take the scenario of this room, I want to give a talk. What do I need? I need a stage, I need a mic, I need an audience who are preferably developers because product managers don't like dependency injection. And so these are my dependencies. So I want to do some stuff, and I have a dependency. So let's say I'm a class. So I need a stage. So how can I get dependencies now? So I could create a setter function. So a setter function would initialize a property within me, and now I have a stage. But setter forces mutability, which means your property within the class has always to be mutable, which is kind of bad if you do it everywhere, because mutability has its own problem, with shared state and synchronization. If we are a multi-threaded environment, I may move left, stage might move right, so I don't want stage to be mutable. We come up with constructors then. Constructors are easy, everyone knows constructors, and we pass values along in constructors. But constructors have a configurability problem because once you declare a constructor, it's like a binding contract. So every time you increase the amount of parameters in constructor, it's like you have to change the code base all over place. Kotlin kind of solves that, and I support Kotlin as a class. So I can have default parameters. So mic is mutable for me, but stage is not mutable for me. So I save mutability. There's a trade-off with default parameters where you're losing mutability, but that's a risk you want to take. So you get default arguments in a constructor. Now, this all is fine. We could just do constructor injection everywhere. We could create constructors for everything. All the class pass on dependency along the constructors, unless you start working for Android. We encounter activities, applications, and services. They don't have constructors. Even if they have constructors, they are start activity intent, start service using intents, and all that stuff. You have got manifest from which main activities are launched. And so how do we inject dependencies in activities? Inversion of control. So inversion of control is a general programming paradigm where it says a class should receive its dependencies from somewhere from outside. Outside is generally a framework or a library which you want to build, or it could be anything within your code base itself. So if I come back to my own example, I need a stage, I need a mic, I need an audience. But when I'm here, everything is already there. I need it, but the control of getting these things has been inverted to me, because this all has been given by conference organizers. So I don't really care about where they came from. I don't know where this stage came from. I don't know where this mic came from, but it's there and I can use it. Inversion of control is something which generally is present in everywhere in life, like outside code also. So if you have seen some websites have like a request a callback button. So let's say Amazon order page. So when you do request a callback, you are inverting the control of the whole call to Amazon or some other website. You don't have to go to call and select one for English, select two for orders. You don't have to do that. They will call you back. They will know what your profile is. They will know what your order is. And then this thing is more advantageous. So inversion of control is like a advantageous technique. Inversion of control might be visualized as containers from which dependencies can be extracted. We'll look into that more. Let's say I'm building a simple application. I like dogs, so I want to show photos of dogs. So simple architectural abstraction here. I've got presenters, I've got repositories, and I've got APIs. So when I create a dependency chart for this, most of the stuff depends on each other. Like at an activity level, you don't really care about where your API is there, what your API is there, what your threading is there. It just cares about how UI should be displayed. Similarly, at a presenter level, it needs a repository and a view, and a repository will need an API. So you got a single line chart here of dependencies, which means all of the dependency I can now hold them in a container of sorts, which means I can create a dependency container. APIs are something which are mostly created isolated. I have a repository constructor, I have a presenter constructor. And for my MVP, I have a view contract, which will be provided by my, let's say, activity or fragment, whoever is implementing it. So now in this container, I have repository, I have presenter, I have API, and I have view contract. I can create a class resolving function whose job is to resolve classes out of this. It's like a nicer API to get dependencies out of this container instead of directly referencing them. And then I have presenter and repository. In repository, I can get the API. In presenter, I can get the view and repository, all the dependencies which it needs. Similarly, when it comes to activity, I can get presenter. Now, all of these are coming from the class resolving function which we had in the dependency container. And the only thing activity needs to do is initialize that container using the view, because that is something the container cannot resolve itself. So, and all of them are injected lazily, which is like Kotlin lazy delegates. So they won't be initialized when they are called, unless they are called. So we have dependencies in a container, right? So, which is fine. But what we created here is a service locator. Because what we are doing is, I have one class which is providing dependencies to all of the classes. So service locators are another pattern. They came around in Java server side where services were present to compose data, find data, and do other stuff. So service locators were like classes who would initialize and configure these all these classes, and then your other classes can ask service locator for an instance of these classes. The problem with service locators is that they become like one giant humongous class on which everything in your app depends on. And if they themselves are not configurable, you lose all it breaks abstraction out of everything within your app. The solution is very simple. You use, again, constructor injection, because the moment you have everything passed around with constructor, your classes are completely abstracted out. So the classes only need dependencies which they need, and they don't really care about anything outside. So this can work out for your dog repository, this can work out for your presenter, but this cannot obviously work out for your activity, because activity does not have a constructor. So we don't depend on service locator for repository and presenter, but we do it for activity. So now the container job of exposing dependencies we have reduced, but it's still going to configure it, because we don't want to do that in presenter, repository, or anywhere. We want to just initialize a container, let it configure, but the classes themselves get dependencies themselves. So they are like completely abstracted out and completely testable in that case. The activity code remains the same. We still have service locator, which is from where we request the dependency, and this is OK. Now, this is kind of like a nice thing because we have an architectural abstraction. We have a dependency container. We are able to test most of the classes around presenters and repository. So I'm talking about unit test cases right now. Instrumentation test cases are also possible. But this cannot scale. So let's say my dog photo startup gets some VC funding, and now I want to show cat photos also, because cats are cute and weird. Similarly, I want people to save those photos. I want people to look at cats photos, dogs photos, save photos of dogs and cats. So suddenly, my single screen app is like now a 5-screen app, which is OK because my startup has to scale. So again, this creates problems because as my number of screens increase, I need automation. I need scoping of these things around classes, and I want things to get done automatically, so I need a framework because I don't want to handwrite everything every time I add a screen. Coming back to Dagger. Again, exciting part. So what will Dagger do? Dagger is a framework for dependency injection, right? So let's start at base. Dagger has something called @inject, which is an annotation. Now, this came out of Java specification requirement 330, which was introduced around 10 years ago to solve Java's own problem with dependency injection. So again, Java had this problem, like there were like tons of framework coming out on the server side, and there was no single API to define dependency injection. So what Java came up with is like @inject. What @inject is like, if you put it on something like a variable, it tells that this variable is now injectable, which means some framework can inject it. This specification requirement does not tell who will inject it, so Java does not really discuss a framework on that who will do a dependency injection, but it says that it's injectable. So when we come to Dagger, there are two ways to configure dependencies. One is an inject constructor. So constructors are always there. Your presenter has a constructor, your repository has a constructor. So if you mark inject around them, it instructs Dagger to create constructors for it, so you don't have to create it. The logic is that once Dagger creates a constructor around them, those dependencies are available for any class to get from. There are classes where constructors are not possible. For example, interfaces, abstract classes, stuff like that. So we have a provides method. So provides, again, does the same thing. Instead of using a constructor, provides expects you to give a concrete implementation of any interfaces which you are using. Multiple provides then reside inside a module. Module provides a cohesive structure around which your dependencies will exist, around user provides annotation. And modules can be modeled around domain, like you could have domain-specific module, like a module for a cat, module for a dog. Or you could even have functionality-specific modules, like a network module or storage module, which could be then shared across application. All the modules then go inside a component. The component is something which sits at the top of the pyramid, and at the top because its job is to wrap up everything, and at the component level, all the dependencies are already there. So you don't have to worry about it. All these things are combined to create what is known as an object graph by Dagger. So it's an acyclic graph because Dagger doesn't allow cyclic dependencies, and it throws a compilation error if you do the same. So every time you request a dependency through Dagger, it gets the dependency from the graph, and most of it is generated at compile time. So if we look back, this is our chart of the dependency which we had earlier, API, repository, presenter, activity. So we've got two interfaces. One is the view contract itself, and another is the retrofit API. So we can model them around provides because these guys don't have a constructor. Now this is the inject annotation we were just talking about. So classes which can have constructor like repository and presenter are marked by inject annotation. So again, we are just telling Dagger, create constructors for this because someone will request it probably. Component is just a plain interface. There's no logic inside it. It has like one function which tells you, bind this to some activity or fragment or any class. And component is just there to wrap up dependencies and, complete the pyramid of it. Of course, it has a module dependency. So, you can have multiple modules, you can have multiple components. Now, injecting dependencies. So again, so we get the @inject, which is now injecting dependencies. So again, with constructor, it was telling Dagger to create constructors, but when you use on variable, it tells it to inject variables into this class. And then we build the component with the module and call something called inject this, which is the method which was present in the component itself. Now let's see what Dagger does when we do all this stuff. So Dagger generates code through annotation. So first thing it generates is the components generated code, which is like Dagger app component if your Dagger dog component if your class name is dog component. So in the component, Dagger tries to find out like what are the dependencies required. So provides are generally concrete, hard implementation, so Dagger doesn't have to create constructors for it. But here you can see it automatically created constructors for presenter as well as repository. And it has factories for API and dog view, which were already there when you create it through provides. Now, when we build that component and we call inject this, we are doing it in a dog, for example, in an activity here. What Dagger does is it calls something called inject, which is present in the generated component of Dagger. This internally calls, these are all generated classes. Member injectors is like the member classes which Dagger has to inject variables into. So it calls something called inject presenter with activity instance and presenter instance. The activity instance is the same one which you called with the inject, and the presenter instance is the one which Dagger created itself. And it's the same thing which you called with inject @late-init var. Now, two things to notice here. Dagger forces your inject variables to be mutable, but it does not forces your inject constructors to be mutable, which means anything where you are injecting variables has to be mutable, which is kind of a trade-off, but you can avoid it by constructors. So if you can wrap anything around constructor, it's always better because you preserve mutability there. The second thing is Dagger pushes dependencies into members of its injecting classes. So instead of activity requesting it, Dagger takes the instance of activity and pushes that dependency into the class, which is different than service locator technique, where you generally ask the service locator for a dependency. So here it's completely opposite. And this is only possible because Dagger does code generation, because otherwise we are reflection, but like reflection is bad and you should probably avoid it. So Dagger has also something called scope. So when you create an object graph out of Dagger, every time you request a dependency, it creates a new dependency. It creates a new instance and gives it to you. The scope is provided to avoid that, though it's like not a really good name for an API, because the only job of scope is to provide single instances. So anytime you create a scope with a component and mark the dependencies in that scope, it always creates one instance of that dependency. And you have got Dagger.singleton, which is like default present in the Dagger. Again, not a good name for API, because singleton doesn't do anything special. Any custom scope which you create does exact same thing as singleton. Now, our job was to achieve like pure inversion of control, because we don't want the classes who are getting dependencies to be aware of where they are getting them from. Dagger does that partially because it pushes dependencies instead of pulling them from some sort of service locator. But the classes are still aware of where they are getting dependencies from, either via a component or a module. So basically, this code is always present in the classes where you are trying to inject activity. One of the reasons is like Dagger is a Java library. It's not an Android library. It's a Java library. You can use it at Java server side also. And this is like a limitation from Dagger's side, because it does not really know about activities application and the whole control flow of Android. So that's why Dagger Android came. Anyone uses Dagger Android here? All right. Am I correct? Now, what we want to do is achieve inversion of control. We want complete decoupling, right? So Dagger Android introduces something called an Android injector. Now, Android injector is something which is like completely integrated with the Android framework APIs. So first of all, what it does is, using Android injector, you can inject directly into activities, services, broadcast receivers, and content providers, which are like the core components of Android, defined core components of Android. And there is like fragments also because, why not? So when you come from, Dagger 2 to Dagger Android, there are a few things which you have to change. For example, modules are not explicitly declared. For example, we had a module for dog which would provide view contract, and we would, build it. But that won't happen now because we are trying to completely remove that part from the activity itself. So modules cannot have constructor parameters. So instead, either you provide parameters within Android, within the function, yeah. Or what you do is you do something called binds. Binds is again another annotation which like Dagger uses to bind something to something. Like here, when I say view to activity, I'm trying to bind view to the activity. So it says to Dagger, you can get view contract from this activity, and you can because it implements it. A new module, this is something new which you have to do when you come to Dagger Android. Like, since we are trying to decouple activities completely, we create something called a build module where we do contributes Android injector. So what it tells is like Android injector has to be contributed to this class so that it can inject dependencies in this class. And you, along with the contributes Android injector, you also tell modules that this class needs this module, and now Android injector should inject these dependencies into this class. This can be multiple, like depending on number of activities and fragments you have. Then you create a single component at application level. So this is like required. So as I said, like Dagger Android deeply integrates into framework APIs. Like you now need to have an application level component which works with apps. So at the last line, you can see the inject will be called at the application of your class, which now needs to exist. Earlier it was not required, but now it is required. Now this component itself depends on multiple modules. One is the builders modules, which will tell Android injector like these are the activities and all the fragments on which you need to inject these things, and the Android injection module, which is like Dagger's internal module. Any other module which has to be present in application class can also be provided in the modules list of this. Now, when you come to activity, you just do Android injection.inject this. So, and you inject, the inject remains same. The injecting property remains same. There is no difference. So what happens here is like you have completely removed the app component thing. You have completely removed the module thing. Any module which you created for this activity or any other activity does not exist. The only thing it is importing is Android injection. So Android injection, what it does is like you can only call it on these things, not any other thing. Like if you have a custom view or something, you cannot call Android injector or Android injection on this. So it again works on concept of how Android works. So you always have application at the top level, and then you have a level where your services, activities, fragments will exist. So what Dagger Android tries to do is like Android injection can find injectors from application. So we are configuring the main component at application level. So we can declare injectors for activities, services, and other things at the top level. And these can then be found out by the activity or service. Like you can do activity.getApplication or service.getApplication. This is something Dagger does internally. So if you define interfaces at application level, you can then configure injectors for all of them at application level. Edge case is fragments, where you can configure injector for fragment at activity level also, because activities can manage fragments themselves. So in application level, let's say I want to inject dependencies in an activity. So what I will do is I will implement interface called hasActivityInjector. It will ask for an override function called activity injector, like I need an activity injector. And I'll just inject it using a variable. I'll tell you where that comes from. And we build the main component. So this is the only component which will be built in your whole code. So there are no any other components which are going to be built. Now, if we come back to when we built Elp component, we had a builder module which was contributing an Android injector, where we bound the activity. So what happens whenever you create a contributes Android injector? What Dagger does is it internally creates a submodule. Subcomponent. Subcomponents are like normal components, but they can inherit properties of main component. Like if you create a subcomponent with a parent class, it gets the dependencies inside parent class also. And it implements an interface called Android injector. So yeah, which has a single method called inject this, which is same as Android injection.inject this. So what this subcomponent does is now, once you have a subcomponent, you have all the dependencies which that subcomponent needs through the modules which it provided in the contribute standard injector, which means at an activity level, now you know all the dependencies of that. Now, those dependencies using the subcomponent are wrapped into a provider. Now, there might be multiple providers present because you have multiple activities or multiple fragments. Now, all of these providers are put into a map, where the key of the class on where you want to inject this is the key of the map. Now, this map is used to create a new dispatching Android injector. So you now have an Android injector with a map of dependencies or on every activity, on every fragment you want to inject into. And all of this then goes to your app component, which is the same which you are injecting in the application class. So when the moment you call @inject in the application class, it now has an Android injector with dependencies of the activities inside it. And in the activity class, when you call this thing Android injection.inject this, it finds the Android injector from application, like activity can get application and find out injector from it. It finds out the injector. From the injector, now it has subcomponents. So the flow has reversed because subcomponent now, the subcomponent was created for this activity on which injection is being called. So the moment that calls, that subcomponent will now call inject dog activity. Now the flow remains same as what there was in Dagger 2. You already have an instance of activity. Your presenter was already created. Your repository constructors were already created. And now you have like everything. There is also one more party trick. So there is like Dagger app compat activity. So if you do that, you don't have to call Android injection or inject this, and you have like just do @inject, which is like a standard Java API, and then you get like pure inversion of control. So now my activity or application my activity don't really know where the dependencies are coming from, but you are getting it. So this is what pure IOC looks like. So we were able to decouple everything, right? We had a problem initially that activities knew about their components, activity knew about their modules, which is a bit problem because if you if you do breaking changes in components and modules, you start modifying code inside activities and UI, which you should not do. So we achieve complete composition using decoupling. So our UI is completely decoupled now. Like the composition of all the dependencies at one side and the UI is at other side. The only thing your UI is doing is like Android injection.inject this, which is like slightly okay because it's still better that if you do breaking changes in Dagger components, your UI doesn't get affected. Now, but is it worth it? Is that decoupling worth it? Is it a problem you're trying to solve? Because Dagger is like a very controversial topic, especially since last month. And again, like it depends on your team size, it depends on your team dynamics. Do you want to do this? Like, do you have time to speed up your team to all the Dagger things? For example, I have like this cat and dog thing, and with 5 screens, I'm able to build it. What happens when I want to get someone on my team who has like minimal knowledge of Dagger, or Dagger 1, or Dagger 2, or Dagger Android? What happens then? Like, how much time would I want to train him? And generally, I've seen with projects like somebody integrates Dagger, like the core is created, and then people just keep adding lines in modules and components. Then you have like components with like 500 lines of code, and everyone is like, this is working until it stops. And then everyone like, I don't understand this error. So, which is a problem. Like Dagger has error problem that I will accept, but yeah. So Dagger also has like a behemoth problem that once you start growing on it, people tend to forget how it used to work. So alternatives. At this point, I feel as an Android developer, if you have a problem, the solution is probably this thing. Why Kotlin? Again, so when we come to the field of dependency injection, you have like delegation. So if you looked at the first example, I was using lazy delegation. So if you're not doing code generation, lazy delegate is really nice. It does create an anonymous class, which is like a bit of a performance problem. But then you get a lot of stuff like lazy delegation means you can access properties without initializing them. You've got lambdas, which means you can pass around functions which can contain more data than parameters of a function. And then you have like DSLs, which mean domain-specific language, domain-specific thing. So you can create something very domain-specific and which is limited to the DI framework itself. So addressing the elephant in the room, I'm going to talk about Koin. So Koin is a dependency injection framework. It is completely written in Kotlin, and it works with Android and Java projects. So it's not specifically made for Android. It's not specifically made for Java projects. It's just like a Kotlin library. It does not use code generation. It does not use reflection. So I'm going to explain what it does actually. And it's completely made using lambdas, extensions, all the nice things you get in Kotlin. Everything is there in Koin. So at a very base level, Koin does not have concept of components, but it does have concept of modules. So in modules, you can declare stuff. So like instead of using annotation, you use DSL. So this is all DSL, like module, single, factory. So single is like singleton, and factory is like creating an instance every time. So Koin's API actually, when you see a Koin API, it's like, if it's written single, it's actually single. It's not like singleton does not do anything. And in your application, you just call start Koin, again, another DSL. You provide Android's context to it, and you load a list of modules. And boom, you're done. And in your activity, you just call something called inject, and you can pass parameters around in inject also. One difference is you have to declare everything in Koin, which means when you're doing modules, you have to declare all the constructors and everything. And if you see this thing called get, it's Koin's way of retrieving dependencies in a non-lazy way. And when you do inject, it's a way of doing it's a way of retrieving dependency in a lazy way. Koin's internal usage is as simple as what it looks like. What Koin does is when you load modules, it takes all the dependencies from the modules, puts them into something called a bean registry, which is a set of dependencies. And when you call, they are retrieved from the set. That's it. And yes, you guessed it right. Koin is like a big fat service locator. So again, coming to scopes and modules, Koin also has a API scope, but it's exactly how it sounds like. Unlike Dagger, where scope is like a kind of a weird thing. So by default, Koin will have a global scope, where you can load modules and unload modules whenever you want. So if you don't want to create your custom scopes, you can use that. But you can create custom scope also. So scopes can be created by name. So you can create a scope by name and open a scope and then clear a scope. But with Android, like if you're binding to an activity, Koin also has an internal API where you can create scopes of activities. So you can declare a variable within a scope of activity, and what it does is, when you inject it, you use current scope.inject. So current scope is an extension function on top of lifecycle owner. So basically, this scope is created and cleared depending on the lifecycle of that activity. So the moment on destroy is called, that scope is cleared automatically. So you don't have to do anything. Advantages. Koin is super easy to use. One of the reasons is Kotlin itself. Like its API is so easy, and you just write it and you are done with it. There is no code generation. Koin has drop-in support for Android, so you can actually inject view models directly within modules, and you have like good support of scopes with activities and fragments. And Koin has like one of the best documentation I have ever seen, and like there are GitHub samples which are updated regularly with releases, so it's easy to get started too. Also, Koin has testing support, so basically modules which you declare can be mocked anytime, and their implementation can be changed at runtime using the testing support library, so you can mock anything around modules. Koin lacks compile time safety as well as automatic constructor generation. So when I say lack of compile time safety, any wrong configuration in Koin will probably lead to a runtime error. Unlike Dagger, where mostly you will get a compile time error. Automatic constructors are not there because Koin neither uses reflection nor code generation, so that facility is not available. Koin does have a reflection module, but again, reflection is a tricky thing. The reason why I highlight these points is because as your project grows or your team grows, lack of compile time safety is a headache which you don't want to have. Like, it's not there in Dagger, and it elongates your feedback cycle because you fail at runtime. and if any scenario is skipped by a QA and some wrong configuration is done, you end up having crash in production. It's rare, but it can happen. With Dagger, it's like impossible. Also, automatic constructors are like very nifty features of Dagger if your project is big, because with Dagger, you can create a base layer of components, and the second layer of components, it will automatically create for you, and then you can inject them, which is really nice when you have a big project because your base layers are always created, and then you can just inject constructors everywhere, and you don't have to care about who is making them. So it's like automation. So you don't get automation. So do you need dependency injection? How many of you say yes for this? All right. Probably yes, and probably you're already doing it. Every time you create a custom view, pass context to it, you are doing dependency injection to that context view, custom view, because custom view does not know where the context came from. It could be fragment or activity. So yes, you do need dependency injection and principles around it, because they promote abstractions and a better structure for your code, which will help in refactoring, testing, and your code will look nice. So do you need DI frameworks? It depends. I have met a lot of people who have not used DI frameworks, and some of them are doing their own manual dependency injection using Kotlin or Java. They have like their own big layer, even in larger applications. The first application which I shipped did not have a DI framework, and it worked fine for years. So again, it depends, because it depends on your team size. It depends on what you want to learn. It depends on what kind of problems you're trying to solve. So if you're trying to solve problems around composition and decoupling, sure, you need proper inversion of control. But if you're not, you might be doing over-engineering around it. So you have to be usable first. Dependency injection says you should be reusable. Framework says you should be reusable. But again, frameworks are here to help you. It's not the other way around. So if frameworks don't help you, you should probably ditch them. Again, Dagger itself is like one of the frameworks in a long line of frameworks. We had Juice, we had RoboJuice, Dagger 1, Dagger 2. Since Kotlin, we have got like Koin, Koin, Katana. We'll have more frameworks which will probably start with letter K. So I don't know why Kotlin frameworks are always made with letter K. So the point is, Kotlin has kind of changed the whole ecosystem itself, and it probably will change this dependency injection ecosystem as well, because libraries like this are getting popular. And if you look at your day-to-day workflow, you've got like Kotlin as a language for Android. You've got KTX as extension functions. You've got Jetpack Compose. So one of the reasons like Koin is getting so much traction is because it's so easy to write. So even if you don't agree on principles of service locators or inversion of control, you cannot deny the fact that it's like very easy. This is something like libraries like Dagger could even use. They could work on Kotlin. They could use Kotlin compiler plugins to solve problems around annotation processors. So yeah, this thing probably will change. I don't know when, but yeah, Kotlin is the future. So here are some resources. So if you're into Dagger or Dagger Android and pretty advanced into it, this is like one of the best presentations around Dagger Android on its advanced usage, because it shows how you can create constructors for views and how Android in future will have constructor for activities also. So if your activities become injectable, that's like your dream coming true. If you're into manual dependency injection, the second one is a GitHub repository by Sam Edwards. So it uses manual dependency injection using Kotlin. So it has like really nice things around lambdas and interfaces. So if you want to scale your own manual DI thing, I would suggest you probably start here. Thank you for your patience, and thank you for listening about dependency injection. I know it's a bit controversial topic, but yeah, so thanks. Any questions?